Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Man's Not Hot by Mello Robinson. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region, which is a box. We have dots separate a line into segments, and digits do not repeat in a segment. The sum of each segment must satisfy the times and equal signs in the dot. For example, the sum of the first segment times the sum of the second segment equals the sum of the third segment. So that means the times of this the sum of this first segment times the sum of this second segment equals the sum of this third segment. Same with this, this, and this, this, and this, this. Oh, this is times, so this is the first segment times the second segment times the third segment equals the sum of the fourth segment. And this is the sum of these three digits plus this, or multiplied with this digit, equals the sum of this segment. So that's how that works. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay, let's take the shortest ones. Those are the most likely the easiest. This is 2 digits at most, so that means that these are adding up to at most 17. But it's basically the product of 2 unique digits. So it could be 16 here. It could be 15, which is 3 and 5. So you can never have, well, you could have 1 and 9. Anything with 1 could possibly be here. 1 and 9, 1 and 8, 1 and 7, yeah, any of those work. This is the sum of 3 digits, so this is 24 at most. And you have a multiplication with another multiplication and another. So I have 3 subsets here. It could be 1 and 1. So we don't really have that many restrictions there. There are no repeats in a segment. Oh, that's interesting. There are no repeats on a segment. That means this can never be cannot be less than 6. This can never be less than 6, right? 1, 2, 3 plus 1, 2 times 1, 2, 3. So that means this is at minimum 36. But it has 1, 2, 3, 4, 5, 6, 7, 8 digits on it. What's the most this could be, actually? Maybe this is the most restrictive one. These aren't that restrictive, with the 1 possibly being there. These 2 digits could add up to 17. These 2 could add up to 17. So 34. And then these digits add up to 30 at most. So 34 plus 30 is 64. 64. And the minimum is 6 times 6. And each of the was it the operands? I don't know. I don't know if it's operand. That doesn't sound right. Each of the factors, I guess. It's not really factor because that's when you use factorization. Each of the things that are contributing to the multiplication must be at least 6. So what does that mean? So again, this could be 8989, 8989. So this You have 6 at minimum. You could have 6 up to 10, essentially. Right? One of these, though, has to be a 4. So it can't be 1, 2, 3, 1, 2, 3. So that means it's at least 6 times 7. So it's at least 42. So one of them at least has to be 7. The minimum could be 6. So it could be 6, 7, 6, 8, 6, 9, or 6, 10. That works. Can 611 work? 66, no. Because that adds up to 60. That's greater than 64, which is the maximum these digits could add up to. So 6, 7, 6, 8, 6, 9, and 6, 10 work. 7, 8 obviously works. 7, 9 could work. 8 and 8 works. 7, 10 does not work. That's 70. And 8 and 8's the max. So we have the possibilities are 6, 7, 6, 8, 6, 9, and 6, 10. Or 7, 8, 7, 9. It could be 7, 7 though, right? Yeah, it could be 7. No, you cannot have. They can't be the same exact set, and they would have to be the same exact set with 1, 2, and 4. So it's 7 and 8, or 7 and 9, or you could have 8 and 8. So that's the possibilities for this blue line here. Okay. What about this? This adds up to at most 34 because you have 2 digits each in the same box. This isn't very restrictive either. So that means these add up to 10 at most. So this would be 1 through 7. That's possibilities here. If you have 6 and 10, you'd have to have. Okay, Hmm. This adds up to 24 at most. So this also adds up to 34 at most. This adds up to 64 at most. This is 17, 24, 34. This is at least a 6. Doesn't tell us very much. Oh, yeah. Um, so 24. Can you ever not have a 1 along this line? So that would be minimum 2 times 3 and plus 4. 2 times 3 plus 4 would be 7 times 2. That's 14. Times another 2. That's 28. So no, 1 definitely has to be along this line. We don't know if it could be there twice, though. That's the problem. It could be 1 here and 1 here, and then this is basically the sum of these 3 digits, which is quite possible. Oh, interesting. So these all share the same columns. So the sum of these combined does have a maximum. So that would be 7, 8, 9 here in column 5. That's 24. Plus 6, 7, 8, 9 in column 7. That's 30, so it's 54. Plus 5, 6, 7, 8, 9 in column 6. So 24 plus 30 plus 35. 24 plus 30 is 54. Plus 35 is 89. Well, but this could be not 1. Huh. Does that tell us anything? I'm not really sure. One interesting thing is, so if this is 6, say this was 6 and 7, that would guarantee these are 1, 2, 3, 4. So this is at minimum 5. Well, if that were the case, it would have to be 6 here, and this is 5. Can that work? So 5, and this is 1, 2, and 3 at minimum. Because again, you can't have repeats along a segment. So that's 6 times 5. This would be 30. This again would have to be 1, 2, 3, 4. 1, 2, 3, 4. Seems okay. This would be 30, and this would be 42. That seems okay. What happens if this is 1? That's actually an interesting aspect. If this is 1, you cannot have 1 here. That means this has to be 2, 3, 4, and 5. Wouldn't that guarantee this has to be 1 and 1 here? That's possible. 2 and 5, and 3 and 4 add up to 8. So that's possible too. Ugh. So that works too. What other possibilities do we have? We know there's a 1 somewhere along here. But... So what does that mean? That means none of these could be 1. I don't know if that's helpful. Because one could be here and here, in which case then that, will basically make things quite there's a lot, there won't be that many restrictions here. We just know this can't be 1 because that would eliminate 1 from this entire line, and then that would be 2 times 2 at minimum times 3 and plus 4. So that'd be 4 times 28, or 4 times 7, which is 28. Yeah. This could be 1 here, so that's not restrictive at all. I mean, it is, in a sense, restrictive, but not by much. What are the single digits possible, actually, here? 6 times 6 is not possible, so this has to be 1 through 5. Oh, that's interesting. Yeah, it has to be 1 through 5. It can't be 6 because this is at least 6 here. And 6 times 6 would multiply to 36, and that's not possible. This is at most 34. Interesting. So this is also 1 through 5 also, right? Because this is at least 6. And if this is 6 times 6, that would be 36. This is at most 34 here. Huh. So that's decently restrictive. We don't really have any restrictions here because this could be 1 times anything. Obviously, this could be 1 and 1. So then that could make these anything. This could be 1, which could make this essentially anything also. So what about the single digits here? What is this at a minimum? It's 1 times 2 plus 3, so it's 5 at minimum. 5 times 5. Right. 5 times 5 is 25, which is greater than 3 digits. So this has to be 1 through 4 at least. What possible digits? Well, it could be... What are the possible digits here? Obviously, it's 1 and plus 2 is the minimum for this. So that would be 3. 3 times 8 could be 24 times 1, which would be another 24, and that's possible. So this could be 1 through 8. So that's not very restrictive. These could be anything because it could be multiplied by 1 and 1, and that's possible. Yeah. It must multiply to at least 6, but that doesn't really tell us much. So it's 6 through 24. Well, it can't be 6. If this is 6, this is 1, 2, 3. That would mean this is 4, and 4 times at minimum 3 is 12. So obviously it can't be 6. Can't be 7 for the same reasoning. 1, 2, 4, that's 3. 3 times 3 is 9. It could be 1, 2, 5, 8. But then this would be 3 at minimum 3, so it can't be 8. Could it be 9? Yes, 2, 3, 4, 1, 1, and then this adds up to 9. That's perfectly fine. So this is 9 to 24. which is pretty broad. Um, hmm. Okay. Realistically, I think we have to tackle this long one. Everything else is pretty wide open. Um, hmm. These could be anything again because they could be multiplied by 1. So that's part of the problem is figuring out where the ones could be and seeing if there's any restrictions that's going to place on it, right? Excuse me. Hold up. Okay. Oh, that is possible. So 7 cannot be here because that would need to be with 1 and 2. 7 can't be either of these. If this is 7, that's 1 or 2. That would mean this is 3 and 4 at minimum, and that's 8, right? So that would be 10 times 8, which is 80. So 7 can't be here. Can 6 be here? Maybe. No, 6, yeah, could be there. No. 6 would have to be with 1, 3. That would force this to be 2, 4 at least. So 2, 4 plus 1 is 7. 7 times 10 is 70. If we tried to make this 6, 1, 2, that's 3, 4. So that's 9 times 8 at minimum, which is 72. So 6 cannot be either of these. 5 does seem valid, right? First, you can have 5, 1, 2, 3, 4, 3, 4, 1. That multiplies to 64. Or you could have, yeah, 5, 1, 3. That adds up to 9. 2, 4, 2, 4, 1 adds up to 7. 7 times 9 does work as 63. So 5 could be there. Okay. Again, if this is 1, this could be any set of digits. Do we want to try like stuff like, I don't know, 1, 2, 3, 4? Well, we know 1 works here. Okay, so what happens if this is 1? Then this is... I think it has to be 2, 3, 4, 5. Can it ever be 6? Like 2, 3, 4, 6? Well, 2 and 6 are guaranteed to be 8. With 1 would be 9. 3 and 4 are guaranteed to be... So 2 and 6 would be guaranteed with 1. So 2, 6, 1 adds up to 9. 3, 4, 1 adds up to 8. 8 times 9 is 72, which is too big. 3, 6, 1 adds up to 10. So 3, 6, 1 adds up to 10. 2, 4, 1 adds up to 7. So that would be 70, which is too big. So yeah, it'd have to be 2, 3, 4, 5. So this would be 1 here. This would be 1 here. That would be interesting because that would force this not to be 1. But this could be many things. This would be 8 times 8 or 7 times 9. Either one works. So far, that seems to work okay. 1 could not be here, obviously. 1 would have to be one of these two. It could be 7 times 9, too. Or 6 times 10, even. 2, 3, and 4, 5. So any of those work. So assume this was 8 times 8. That would mean this is 8, 9, 8, 9. You'd have to have 6, 7, 8, 9 here. And this would be 8, 9, and 8, 9. Right? So again, 17 times 2 is 34, plus 30 is 64. That would leave these as 1 through 5. So this is at most 6, 7. This is at most 5, 7. But that's 23 as, or 25 as a possibility. Well, it couldn't be 25 then. But, yeah, we don't. So that seems perfectly fine. It's not restrictive. I mean, it's restrictive, but not. It doesn't lead to a contradiction, which is essentially the problem. This would have to be 2 times something. Could be 2 times 3 still, though. 1 can't be here, 1 can't be here. Okay. That's not helpful. Um, okay. Okay, obviously this can't be 1, but this could be anything from 2 through 9, so that's not helpful. What happens if we have a guaranteed 1 and a 1 here? So this couldn't be 1. That means this could add up to 17. That would be 34, so that would be fine. So there really aren't any restrictions there. Hmm. That's not helpful. What other ways can we go about this? I'm gonna pause because I need to go to the bathroom right now. I'll be right back. And I'm back. Let's continue. Hmm. Okay, so one thing that was interesting that I was sort of thinking of was what happens if this is 1, 2, 3, and 1, 2, 4? If that were the case, this would necessarily. Okay, so 1, 2, 3, and 1, 2, 4. These would have to be 1 or 2, right? To accommodate those. Because these add up to 10. These would have to add up to 3. So it's 1, 2, 1, 2 here. So this would be 5. This would have to be a 1, 2, 3 triplet. Well, 3 would have to be here because you couldn't have 3 here. So this would be 1 or 2. This would be 1 or 2. This would have to add up to 30. This would necessarily be 6, 7, 8, 9, 6, 7, 8, 9, 6, 7, 8, 9. That's fine. That would mean these are 3 through 9. That also seems fine. Okay, not 3 through 9, 4 through 9. Because this would be 3. So this would have to add up to 42, which seems okay. This would add up to 30, which seems okay. Is this really restricting us? I don't even know. I'm not really sure where to tackle these, to be blunt. Yeah. I was just thinking, of those restrictions, right? And yeah, this naturally had to be 1 through 5 because these add up to at most 7 and 9, or 6 and 10, or 8 and 8 adds up to at most 16. And those are the maximum values we can add up to, right? So you could have 1 and 1 here, and this could add up to, what, 14? But the problem is you can't have 1, 2, and 3 with 8, right? 8 and 1 must naturally add up with 2, so that's 11. And 11 times 6 at minimum is 66, so that's why you can't have 8. These are 5 at most because 1 and 5 add up to 6. This is at minimum 1, 2, 3, 4, which is 10. So there's always going to be that. These don't really matter if, you know. Oh, that is interesting. If this is 7, 8, 9, what is the maximum for this? It would be 5 and 6 here, and it could be 8, 9 here. So it's 11 plus 17, which is 28. That's still pretty wide. It could be 4 here, then, which isn't that helpful. Hmm. Uh, hmm. Um. Yeah, I'm not sure. Yeah. Okay, what happens if this is 8? 8, 1, 2. This is 1. This is 2. This is 1. That means this is 7, 8, 9. That seems fine. This can't be 1. This can't be 1. This can't be 2. Obviously, it can't be here, but that doesn't really matter. This can't be 5 because it can no longer add up to 30 at most. This is what? 2, 3, 5, 4, 2, 3, 4, 5, 6. This can't be 1 or 2. Oh, that's interesting. So this is at least 3. That means this is at most 18, but that still could be pretty broad. It's just, yeah, this isn't very restrictive. So the question is, where am I going to get the most restrictions or lead to a contradiction, at least? That means this can never be 5, because again, these two must add up to at most 6. This can no longer be 8 and 9, though. So therefore, this adds up to at most 63, but it still could be 7 and 9 here. That's fine. This can no longer be 7, because that would have to be with 2 and 3 at minimum. Hmm. Same with 6. Does that really give us very much information? Not particularly. Uh, this just isn't like there's not that many restrictions that go about from here. Okay, that's not helpful. This is not helpful. I need some sort of, yeah, I've already tried relationships with these and these. Problem is that's still pretty wide. Haven't tried really this or this. We've tried this kind of. 4 times... What about 4 times 1 plus 3? That's 4 times 4 times 2. That's 32. That's too large. So if it's 4, it has to be... It could be 2 plus 4, but this would have to be 1 if that's the case. Okay, does that help us with anything? I don't think so. Right? Even if this is 1, that doesn't restrict anything else here. Heck, we tried to have a 1 here, and that didn't really restrict any of this. Hmm. If this is 7, or this is 7, the other ones have to be 1, 2, 3. So this would not be 1, 2, or 3. This would be 4, 5. But this could be the 1, 2 here, right? 4 times 7 works also. 4 times 8 works also. Right, 32. 4 times 9 would not. So this would be 1 through 5. If it's 5, so this could never be 4. That's not helpful. Because if this is 4, this has to be 5. 5 times 7 is 35, and that's too big. Hmm. That seems fine. It's just, yeah. Not really sure how else to attack this. Yeah. It's just going through all the options. We've tried doing stuff with this. We've tried doing stuff with this. Maybe here? I don't know. It just seems too broad. Okay, is there any rules that I'm missing? I don't think so. Dots separate a line into segments. Digits do not repeat in the segment. The sum of each segment must satisfy the times and equal signs. Sum of the first segment. Yeah. Uh, this doesn't, I mean, this is basically just like this, unfortunately. These add up to at most 16, that's fine. We're not very restricted there. Even if this is not 1, it's still not that restricted. You could have like 2 times 3, right? And this would add up to 6, so it's just like, okay. You can obviously have 1 times 9, so that's not helpful. I don't know how to attack this. It's because the problem is the geometries, right? There's not very many restrictions at all. It's just, yeah, there just aren't very many restrictions. The only restrictions are the number of segments that are part of. Oh! Duh! Each segment, each set digits do not repeat in a segment. So this can't be 64. This is 1, 2, 3, 4, 5, 6, 7, 8. So it's at most 44. Okay, there we go. So this must be 6 and 7. Okay, there we go. This is at most 44. 6 and 8 don't multiply. Multiply to 48. 42. And that's it. Because we can't have 6 times 6 because these 4 must be at least 10. So this has to be this way. Okay, there we go. Yeah, yeah. They just don't repeat on a segment. This is 30 at most. Okay, yep. That was very important. This can't be 1, 2, 3, or 4. This has to be 5. This adds up to 32. No, 42. Right? 6 times 7. This is 5. This must be 1, 2, and 3. So 3 cannot be here. This is 1, 2, 3 triplet. This is 6 times 5, which is 6, 7, 8, 9. So it's 6, 7, 8, 9 there. Okay, that was the key. I had to reread that part. There are no repeats in segments, so this can't be repeated there. Therefore, this is not a 3. It's 2 through 9. No, 1, 2, 4 through 9. Because we're missing a 3 because it's specifically... Right, that many digits. Okay, it's a good thing to read. So this cannot be 7, 8, 9. This is 6, 7, 8, 9. They don't all see this, though. The rest of column 4 is 6 through 9. This is again, at most 30, but this still could be 1 here. We know this is 1, 2, 3, 4. This is 42. This is 4 through 9 here, and 4 through 9 here. This is 6, 7, 8, 9. Three has to be one of these two. This digit is the same as that digit. So I guess we'll mark those the same. This must be different than this digit because these two must add up to... You have... One of these is 2, 3. The other one is 1, 4. Or you have 1, 3 and 2, 4. So that leaves these as different digits, right? Pink cannot be here or here. It can't be here because you can't have a repeat on the segment, so this must be pink here. Green cannot be here or here. This is 3 or 4, so green can't be here because this is the same as that one. So this can't be green. This is 3 or 4, which forces this to be green. Pink is one of these two. That's actually very interesting. I like how that way that segment worked. This green must be on the segment, so must the pink. Pink cannot be any of these. Pink cannot be any of these. Pink can't be here. This must be the pink here, which makes this 1 or 2. Very clever. I like this geometry. Okay, that makes a lot more sense. This is 3. This is the pink. This can't be 1, 2, or 3. This has to be a 4, which means this can't be 4. This can't be 4. This can't be 4. To add up to this, it has to be 1, 2, and 3, I believe, right? If we try 2, 1, and 3, that's already 2. 1 and 3 is 4, plus times 4 is 16, times 2 is 32, and that's too big. So this has to be 1 with 2 and 3. And this adds up to 20. So it could be 3, 5, 6, 7, and 8, and 9. This can't be 3, though. That means 1 and 2 both have to be here. So green and pink both have to be here. That means this can't be green or pink. Green can't be here, here, or here, so this must be the green. 1, 2. Because this adds up to 30, or sorry, 20. And 3, 8, 9 is the minimum here. 5 cannot be here. That means the rest of row 8 is 3, 4, 6, 7, 8, and 9. This is not 3, this is 4, 6, 7, 8, and 9 here. 3 cannot be on this segment because, again, it adds up to 42. Where is the 3? The 3 has to be here in row 8. Can't be here, can't be on the segments. We add up to 42. Therefore, it must be 3, and this must be 8 and 9 to be with it. That 3, 8, 9 triplet eliminates 3, 8, 9 in the rest of the box. This can't be 8, 9. This is 6, 7. That leaves us as 1, 2, 5. This can't be 5. The 6, 7 pair eliminates 6 and 7 on the rest of the segment, so this is 8 and 9. That means this can't be 8 and 9. This can't be 8 and 9. This is a 3, 8, and 9 triplet, which eliminates 8 and 9 in the rest of the row. Interesting. The green has to be on the segment 2. It cannot be here, here, or here. Okay. This is 1, so this cannot be 1. 6 and 7 cannot be here. 3 and 4 cannot be here. 3 can never be on the segment. So 4 could be... This is 4 through 9. Cannot be 6, 7. This is 4 through 9. Can't be 6, 7. 4 through 9. 4 through 9. Okay. 3 in box 6. Okay, this can't be 4. 3 in box 6 has to be in columns 8 or 9. 3 in box 9 has to be in columns 8 or 9. That eliminates 3 in the rest of columns 8 or 9. This can't be 3. 3 has to be one of these 3. It cannot be on this segment because this adds up to 42 with 8 digits. What does that mean? I'm not sure. So 3 could be here. 3 could be here. We don't know. 3 cannot be here. In box 2, 3 has to be one of those 4. That's interesting. Can this ever be... well, it could be 3. It's possible. Okay, we have 8, 9 pairs now, too. So make this yellow and orange. That means this can't be orange, so this is orange here. Yellow has to be one of these 2. Orange cannot be here or any of these. So orange has to be here, here, or here. That's fine. Remaining digits. Okay, where's 3 in box 8? Can't be here, can't be any of these, so this must be a 3 here. That leaves the remaining digits in row 9 as 4, 6, 7, 8, 9. 4 has to be one of these 3 because 4 cannot be here or here. That means this can't be 4. Where is the 4 in row 8? It has to be here, so that's 4. Which means 4 has to be one of these 3 digits here. 3 cannot be here, so 3 is one of these 2. 4 can no longer be on the line because we already have a 4 on the line. That's interesting. Remaining digits in row... This has to be 6 or 7. We have a 6, 7, 6, 7 pair. That leaves the remaining digits in row 7 as 5, 8, and 9. So 5 has to be one of these two, and then we have 8 and 9, so that's the yellow 8 or 9 here. Okay. Um, hmm. Where's pink? So this can't be green or pink. So this must be 3 through 9. Pink. This can't be pink. So pink is one of these two. Green can't be here, so green is one of those two. Green cannot be here, so green has to be one of these three. Green can't be here. Oh, so where is the green on this line? Cannot be here, can't be here, can't be any of these, or this segment. So green can't be here, here, or here. That means green is either here or here. And since green is here or here, this can't be green, so this is pink, which means this can't be pink. So pinks are all ones. So this is 1. That means these greens are all 2, so this has to be 2. This is green, so this can't be green. So green has to be either here again or here. We don't know which. So all the greens are 2s. That makes this a 3, which means this can't be 3. This is 4, which makes this not 4, so that's 3. 4 can no longer be here. 4 can't be on this line again. Where's the 4 in box 6? It has to be here. So this is 4. This is 2. This still could be 1 here. Okay, so 2. That means this can't be 2 here. 3 cannot be here. Therefore, where's the 3? In box 9, it has to be here. This is no longer the yellow as a possibility. So this is yellow. This is orange. 2 is one of these two. We're not sure which. Okay, what are the remaining digits on this segment? It has to be 2, 5, 6, 7, 8, 9. Okay, this can't be 2. 2, 5, 6, 7, 8, 9. 5, 6, 7, 8, 9. 2, 5, 6, 7, 8, 9. No 6 or 7 here because of the 6, 7 pair in the column. We have a 2, 5, 8, 9 quadruplet in column 7, which eliminates 2, 5, 8, 9 in the rest of the column. Therefore, this must be a 3, 4 pair here. This is 3 and 4. This is 3 or 4. Where's the 1 in row 6? It has to be here. So this is 1. Aha! This can't be 1 or 2. Okay. So we can remove the pinks and the greens. We know which ones are which. So the 1s remaining have to be one of these two, one of these two. This can no longer be 1. This is 2 or 5. That's interesting. 1 can be any of these 4, so it's pretty broad. Okay. This cannot be 1 times anything now. So it adds up to at most 17. So we could have 16, but that would have to be 4 and 4, which is not allowed. 3 times 4 works. 3 times 5 works. 3 times 6 does not. One of these has to be a 3, I think. Right, so it's 3 times 4 or 3 times 5. This can't be 4 anymore. Where's the 2 in row 4? It must be one of these two cells because this can't be 2 because of the 2 in the box. This can't be 2 because 2 in the box. So this is either 3, 4, or 3, 5. 3, 6 doesn't work because that's 18 and 2 digits can never add up to 18. 4 and 5 multiplied to 20. So that's too big too. So this is either 12 or 15. We're not sure which. 3 has to be here. 3 could be here. Except the 3 in a row. So this can't be 3. This can't be 3. This can't be 3. Therefore, that makes this a 3 here. If this is 5, 1 cannot be on this. So 5 would have to be with that minimum 2, 3, and 4. And that would be too large. 2, 3, 4 adds up to 9. 5 times 9 is 40. And you can never have 40 on 4 unique digits. So this is 2, which means this can't be 2. This is a 1, 5 pair, which eliminates 1 and 5 in the rest of the box. So this must be 2 here. This can't be 2, so the 2 on the line has to be here. So this can't be 2 here. 2 cannot be here. 2 can't be here. 2 can't be any of these. So this must be a 2 here. That makes this 3. That means this can't be 3. Where's the 3 in column 1? It has to be here. So this is 3. That makes this 4, which makes this a 3. This is 2 at most. Sorry, 2 at minimum. No 1 here. This cannot contain a 2. It's at minimum 4 and 5. So that's 12, which makes this 24. If we try 3, 2, 4, 5, and 3, 4, and 6, what is that? That's 26, right? 3, 4, and 6 add up to 13 times 2 is 26. That is possible if this is 7, 8, and 9. So, and this cannot be 4, 5, because this is 4 or 5. So if these were both 4 and 5, that would eliminate all possibilities for this cell. So this must be 4 and 6 to multiply to 26, right? 2, 3, 3, 4, and 6 add up to 13, which times 2 is 26. 2, 7, 8, and 9 at minimum add up to, at maximum add up to 26, which is the 26 that's here. Therefore, this can't be 7, 8, 9. This has to be the 1 now. These cells all see this cell, so that's why this can't be 7, 8, or 9. This is a 4, 6 pair, which means this can't be 4, 6. This is 5. That means this adds up to 15. So 6, 7, 8, 9 is possibility 6, 9, or 7, 8. 7, 8, 9. This can't be, this 5 eliminates 5 here. This can't be 7, 8, 9. So this is also 4 or 6. That forces this to be 7, 8, 9 here. This can't be 5, so the 5 has to be here, which means this is not yellow. 5 has to be one of these two. We have a 4, 6. This can't be 5 because of the 5 in the row. Therefore, this is at 8 and 9. We're not sure which one it is. Where is the 7 in row 2? It has to be one of these two. So therefore, this can't be 7. This matches this cell. That's all we know. This 4 eliminates 4 here, so this is 6, which makes this 4. This can't be 4. This 4, 6 pair eliminates 4 and 6 in the rest of row 1, so the rest of row 1 must be 5, 7, 8, 9. This 6 eliminates 6 here. We have 1, 5, 7, 8, 9 here. Six must be one of these 3 digits. That's fine. 4 eliminates 4 here. That leaves us as 5 through 9. Remaining of row 4 is 5 through 9 also. This can't be 5 though because of the 5 in the column. This still could be 4, 6, 7, 8, 9. 5 again is one of those two. This can't be 4. 4 has to be one of these two. Ah, where's the 4 in column 2? It has to be here. So this is 4, which means this can't be 4. This can't be 4. That means the orange 8, 9 has to be one of these two digits. We don't know which. This is actually not that helpful here. So let's uncolor these, I guess. Maybe we can find something along here that's helpful. Or 6 and 7s, I don't know. This is 5 through 9 also. And, well, it could be this one. Dang it. I think we have... No, we don't have all the ones. Oof. We have all the 2s. We should have all the 3s. We should have all the 4s? No, we don't have all the 4s either. Ugh. That's not good. This is 15. That's not helpful. This is already 30. That's done. Dang it. This digit has to be the same as one of these two. Oh, this digit is the same as that one. We know that for certain. So, because this digit cannot be here. This digit is the same as that one. This is orange. That means... What does that mean? I don't know. Where is the yellow 8 and 9 in box 2? Can't be here. This is matching that, right? And it sees these are the distinct, unique digits on this line. Can't be here. Can't be here. It must be here. So this is the yellow 8, 9. Also, the yellow 8, 9 cannot be on this line. Does that help us? Not particularly. This pink cannot be here. So it must be one of these two. Oh, okay. This is an 8. No, we have an 8, 9, 8, 9 pair in column 6. That eliminates 8 and 9 in the rest of the column. So this is a 5, 6, 7 triplet. Pink cannot be here. So it must be one of these two. That doesn't tell us very much. Hmm. Hmm. Do we have anything with 6 and 7s? So that was actually pretty useful, but I don't see it helping anywhere else. Well, we do know this is the same as that. Okay, that's kind of helpful. So yellow cannot be here, so this is yellow, which makes this yellow. So yellow has to be one of those three. Yellow cannot be here, yellow cannot be here, so this must be yellow here, which makes this 8 and 9. Yellow can't be here, or here, or here, so this must be yellow, which makes this 8 and 9. Okay, so that is pretty helpful. That forces this to be yellow here. That makes this a 6, 7 pair. That means we have a 6, 7 pair in column 2, which eliminates 6 and 7 in the rest of the column. This can't be 7. Therefore, this is a 7. This must be 8, 9 as a pink. So this is not, well, this is orange. It's still 7. That means this is pink to match that. And the reason why we knew this is these added up to 15. So it's 6, 7 adding up with 8 and 9. That means one of these is guaranteed to be the pink. This can't be pink. This can't be 8 and 9. This can't be 8 or 9. This is a 5, 6, 7 triplet, which eliminates 5, 6, and 7 in the rest of the row. So this is 1, 8, 9 as a triplet. This 8, 9 pair eliminates 8 and 9 here, so this is a 5, 7 pair. This can't be 8 or 9, and this is 5, 6, 7 as a triplet. Therefore, this is not 5. This is 8 or 9. That makes an 8, 9, 8, 9 pair in row 5, which eliminates 8 and 9 in the rest of the row. This can't be 8 and 9. This can't be 8 and 9. This can't be 8 and 9. So this is the pink 8 and 9. This can't be 8 and 9. This is a 5, which means none of these can be 5. This cannot be 8 and 9 because of the 8 and 9 pair in the box. So this is 6, 7. That eliminates 6 and 7 in the rest of the column. So this is 5. This is 7. This can't be 5. That's 1 and 5. This can't be 1. It must be the pink 8, 9, which forces this to be 1. This is then pink 8, 9. This is the corresponding yellow 6, 7 to add up to 15. This is the pink 6, 7. That means this is the pink 6, 7 here. This has to be a 5 because there's no other place for 5 in row 4. We have a 6, 7, 6, 7 pair, which eliminates 6 and 7 in the rest of the row. So this is an 8, 9, pink 8, 9. This can't be 8 or 9 here. This can't be 5. Where is the 5 in box 4? It has to be here. So this is 5. This 7 eliminates 7 here, and this is the pink 6, 7. Therefore, these are all 6s. So since these are all 6s, that means the yellow 6, 7 has to be 7. The yellow 8 and 9s have to be 8. And the pink 8 and 9s have to be 9. That 6 eliminates 6 here, so this is 4, which makes that 6. This can't be 6 or 7, so that's 4. This 6 eliminates 6 here, so that's 7. This can't be 7 or 5, so that's 6, which means neither of these are 6. This is a 5-7 pair. Where is the 6 on this line? It has to be here, so that's 6. This is 7. This is 6. This is 7, which makes this 6 and 7. This can no longer be 7 or 6, so it's 5, which forces this to be 7. Uh-oh. We have a contradiction somewhere. Oh, we have too many 9s. Okay. Where is that? Oh, I think it was this. Right. Oh. Well, this does have to be 9, though. This has to be 9. So this has to be 9 here. So those are good. So that's 9. And then everything flows from that, right? This 6 eliminates 6 here. It's 4 and 6. This can't be 6 or 7, so it's 4. This can't be 6, 8, or 9, so it's 7, which makes that 6, which makes this 7. This 6 also makes this 7, which makes that 6, which makes that 7. These can't be 5. It's a 6-7 pair. This 6 eliminates 6 here, so it's 7. This can't be 5 or 7, so that's 6. That makes this a 7, which makes that 5, and therefore that's a 6. Apologies for that. Well, it wasn't that major. It was just basically, I just didn't realize that these were added automatically, but this was correct, this was not. And then, yeah, everything flowed from there. I got stuck on this segment. I didn't realize that this segment had to be 42. That was a pretty major issue. I was trying all other sorts of things, and then I reread the rules. So that shows rereading the rules is important. Anyways, I hope you enjoyed my struggling through this, and I'll see you next time on Frank Puzzles. Take care.